And this is a very interesting thing. If you of the design patterns you know in object-oriented learning, many of them disappear. So dependency injection, if you can pass lambdas, you can inject anything.
Unit command and strategy will go.
Exactly. So this is even more general than this. So we've actually disappeared pattern, that you need a pattern and an idea for it in object-oriented, but linguistically in functional, you can actually just solve it. And it actually happens quite a bit in the design patterns. There's if you look on the web, you'll find papers about the design patterns, the gamma design patterns disappearing in dynamic programming and functional. And so keep this in mind as you go into functional, that your old problems might go away, and to be sure, you'll find new ones, so don't worry.
So certain structures, just because the language is absorbed in it, the whole thing, those structures no longer appear the same, and they appear very different, as you said. Now watch out for the newer ones. So
Yes. Yeah.
Cool. So, Risha? Something like that? Or should we do the whole thing?
You have access to the net on my phone.
Yeah.
I've just tweeted.
Oh, you tweeted us? Okay. So we have a tweetable course?
I've tweeted a link to it.
Oh, okay. Just link to it.
कितना ऑन करना
Ruby, the language itself has a lot of support for functions programming and taking functions as parameters primarily. So in Ruby, any method actually can accept a block of code using the do end or the curly bracket syntax. So basically, a curly bracket or a do end encapsulates a block of runnable code. So you can think of it as a lambda with a few minor differences. So this method sign basically is taking an initial value of time. When it's calling yield is a keyword in Ruby, and what that does is, if you have passed a block to any method, it just invokes that method. It invokes that block. And you can even pass parameters to the block, but giving the parameters to yield. So you can think of yield as an implicit function call to the block that you have passed to the method. And you can pass it parameters, the block can return a value, and yield will return the value that the block will return. So what I'm doing is, in the method per time, I'm saving the before time, and just calling yield, the method will do, the block will do whatever it needs to, and it will return, and I'm returning time but now mine. So there's no explicit accepting a function. That's just built into the language in Ruby. And you'll see
That's something new for me.
So this is the lambda analogy. So do end, and here's your lambda, and there's your injection.
Yes.
So that's sugar for the block that gets passed in for.
Yes. And in Ruby, any method has access to yield. And you see this a lot in idiomatic Ruby, where people pass around blocks to end. And if I'm not mistaken, I think in Ruby, if you write a for loop, that's actually syntactic sugar over called each. So it's the other way around. The explicit declaration is in fact executable over a called each. And yeah, you see such code all the time.
So the thing that I learned was this whole thing is implicit. There is no explicit parameter. So
Yeah.
it's a good thing.
And especially when new people take to Rails, they see a lot of this do and kind of stuff. It's important to know that you're actually passing runnable code to some other method, which is then going to call it and do something with it.
Cool, thanks. I mean, I think we, in terms of, we've got a C# solution here also, but I think, unfortunately, what I would suggest now is we get your code into it just maybe like this, or share it on the Jugalbandi so that we can all, on the Jugalbandi Twitter account, just tweet it there.
Oh, you did it for Scala?
And, right?
So let's just look at that quickly. Do you want to explain it, Rick?
So this is the basic function syntax. This is the computation function, which takes the duration and it simply computes. It doesn't return anything. It returns singularity. What I've done is I have passed this function as a parameter here. I have specified its signature that takes an integer and returns singularity. And along with that, I have also passed the value that will be the duration for which this function will be invoked. That's what I've done. I've started computing. I mean, this is the timer. That's start time. Then there's end time here. And here I'm invoking the function with the given value. And just to print it out, I invoke the time with a duration of 2000 milliseconds. So the beauty, another thing that I was trying to do was, what if I want to do this repeatedly for multiple durations? So what I did was I created a list of different durations. I mapped them. I mapped them to a time.
Oh,
Okay.
So a list of computations.
Yes.
Very nice.
Cool.
Okay.
So I just want to keep doing what I've been doing. Here's that same pattern again. We're passing in the function, injecting it, but look, the typing we need to be much more explicit about in Scala. Not a bad thing, but I'm just pointing it out. Great, nice solution.
I'll just paste C# code. So it started like this. Which it is? So I'm just going to make this with a Java code. Is it because the second icon? Okay, thank you.
This one is the aspect-oriented programming. It's the classic way of doing it in C#. Definitely, there is a better way of doing it with the functional programming, which is F# and using lambda expressions, which is probably similar to what we had shown earlier. So this is a typical C#. You can scroll down completely here. So yeah. So I'm using the PostSharp third-party library for creating my aspect. So this is my timing aspect which I'm creating, and in timing aspect I'm just kind of doing whatever stuff I want. it's on entry and on exit of every method. What happens is it registers the stopwatch and it automatically prints the start time and driving time. So this is just an aspect which I've created using a aspect oriented program, and you can now shift back. So I had multiple these functions. I've created 3 functions. So I just put it as an attribute to the method, which gives me an aspect. So with every run of the method, the aspect would be called and the timings would be registered. So you really don't have to do anything else. You just register the aspect and that's how you do it. Yeah, but definitely there is a better way of doing it through H sharp.
Yeah. But that's very interesting because object-oriented programming is really where in an OO setting, this is how you would, exactly how you would address it.
Yeah.
And it gives you the ability to write, to amend a function outside of the function. Very nice. Thanks.
I think, yeah.
So, we've got a little bit of a plan left. We've got 45 minutes left. So, we didn't see a solution. You want to share it around to the account.
Jugalbandi, yeah.
Because we want to go into a bit more discussion. And we do refer to these things.
Quickly.
Show your just a space.
Sure.
So when you get into functional programming, I'm sure you've heard people say it will change the way you write object-oriented programming. And we just want to look a bit into what does that mean and how would it change the program. And so the thing is, when you learn a new language, you pick up a new, you have an accent in that language, and you can bring that accent back into your original language. It will affect the accent of your original language. So you're going to be using the same things you understood, but so you can make it.
Yeah.
So possibly one of the key differences between functional programming and imperative style programming is something called differential transparency. And so we're just going to lightly discuss this. There is a melody in the Jugalbandi code base that will that you can read more about this. But we just want to take 10-15 minutes now, just point at that and bring your awareness to it, because it's a really crucial difference between what you're used to and where you might be going.
So once we are through, we'll walk through this list as well.
Yes. So I'm just going to show you the crux, the heart of referential transparency. It's a very simple thing, but it's actually quite far-reaching. So put your thinking hat on.
I'll share a different screen on Hangout, so because just if you can give me a minute. Because
You're not connected to Hangout here.
I think all the time I was.
No, you're not. So you were actually using video.
You
You can quickly join when someone.
Somehow the connection got dropped. Is that what it is? Well, then.
So, calculator class, we're in object-oriented language here on purpose.
Bear with me. Sorry.
Great. So shall we just, so we're not showing that.
Yeah.
Okay, so we have a class with the local, so I think calculator, old school calculator, right? It's got a current state, and I can construct a new one with an existing state. But these are the functions, just bring them to the center. These two things are really what I want to look at. So we've got the class memory plus. So like on a calculator, you might say plus 6, which means memory plus 6 will amend the memory of that class. So it's something that you're doing actually all the time in implementation. If I call memory plus again plus 5, it's 5 plus the previous one. So every time I call memory plus, I may very well get a completely different answer. Most likely I'll get a different answer than the previous call. And so memory plus is said to be not pure. It's not a pure function because what it returns depends on when you called it, in which sequence you called it. If I called memory plus 1 and then 5 and then 10, or 10, 5, 1, the answer of memory plus 5 is actually going to be different. It's going to depend on the order in which, it's going to depend on a broader context in which it was called. So this is something that's happening absolutely all the time in object-oriented programming. You're amending something and you end up with a function or a method really that is giving you different answers all the time. So this is something we experience all the time. The answer depends on the time that you call it, relative to other calls to that mean. This method, this function, add, the same isn't true. I'm taking two numbers and adding them. So if I say 1 plus 1, always going to be 2. It's transparent to time. It doesn't matter when I call add 1 plus 1 in my code. The answer will be the same. And that's said to be referentially transparent, meaning it's transparent to time. It's transparent to the context in which it's called. This is a pure function. I want to just give it to you from another angle. This function add isn't dependent on anything outside of itself. It's just concerned with its parameters. It's taking x and y in, and it's doing something and it's giving you an answer. This method is, we could say it's shooting roots into the class. It's reaching outside of itself. Memory is not a part of this function or method. It's sitting on the class, it's sitting in the container. So it's literally like me reaching outside of myself, grabbing something outside of my scope, changing it, and coming back. And the effect of that is actually quite profound. So we do this a million times in object-oriented code. The effect of this means that this method, if I wanted to test memory plus, I can't test it on its own. I can only test it, the smallest unit that I can test this in is the class that contains it. So if I wanted to test memory plus, I would, in object-oriented testing code, I would say new calculator, memory plus this, memory plus that, assert that the memory is what I want. This function, because it doesn't depend on anything outside of itself, is completely testable on its own. I can write a test just for add. And so this is a huge deal, because you will find that the kind of testing code you write in functional programming can be much more tight. So I might, when I was writing this code, if I wrote it in functional code, I would immediately test the add function. And I could just this little function I can test. And I could write a few tests for it, and I can trust it. If there's another pure function on this class, I can just test that one. Whereas for this one, I'm always testing bigger containers. And so in object-oriented code, the more your methods should root into the surrounding class, the bigger the scope of the testing is. And so that's why in object-oriented test code, you often have to mock things. You have to say, well, I'm not going to set up this whole database connection. I don't have this whole database, this whole big thing that I have to set up outside of the method that I'm testing. So I'm just going to mock it. Now in functional, in more pure functional code, mocking disappears because there's nothing to mock here. I just pass in the parameters I want. And so I'm speaking about it in a way very simply, but it's actually a very big deal because it changes your test code. Your test can be much more focused. And when you're writing the code, you can immediately test little snippets as you go along. Whereas in object orientation, you're often waiting until your class is kind of stabilized a bit or become interesting enough to test. And by the time it is interesting enough to test, you have to test it on the class level. So
to add to, so just to recap, like, so pure function just, the way we would write is, it neither modifies the inputs nor reaches out, as Ryan said. So there's one more thing which I want to add is, it should not even modify the input. And that's why writing final in Java code is a good practice. But in Scala, if you see, all the input parameters are final by default. So you cannot modify any input parameter. And that's one of the good practices. So if you do this, just make sure that, try to make sure that it's final. Never ever modify. That's why we say, as a piece of advice, never ever modify any input parameter. So yeah, that's a pure function, and that's pretty much. This is referentially opaque. This one, and that's referentially transparent.
So, this might not entirely explain it, but at the very least, I would like for you all to take it home that this is actually a very big difference. And this is how your code will change. If you do functional programming and you come back to OO, you'll find yourself writing more pure methods. Because on a class, you might find that a good deal of it can be pure. And because a class is all about having local things that you can mutate, you don't want to move away from that, because that's the whole point of object orientation. But even within imperative object-oriented code, you can actually milk out some pure functions in every class. And the more you do that, the more easily your code will be to maintain and understand. So that I can't convince you of. You have to feel that for yourself. But I'll put that down as a theory for now that you can explore.
I think we can actually show. So when you actually do write code like this, in functional programming, what happens is you try to separate the data out and the behavior out. As Ryan mentioned, this is purely a pure function. It does not really need to probably belong here. It could be moved out. So so I'll just show you this bit of Scala code that is there here. Of course, feel free to take a look at this. This is written in bracket as well. So just if you were to improvise this, before I show Scala code, if you were to improvise this calculator and go the immutable route to make this calculator referentially transparent, you probably don't want to now mutate this memory, right? So each time when you are calling memory plus right here, doing this. And this is very true for value objects that we see, but again, I don't want to go that route because it's a whole new discussion. But this is what now constructed a new calculator with a new memory. If I continue this refactoring mercilessly down, can I separate the data out completely? And look at that, I have the same thing in Scala. And in Scala, typically in functional programming, we have data classes. Data resides separately, and you have functions separately which operate on the data. So this is a case class which just has data as memory, and you have another object as calculator. By the way, in Scala, when you write object, you get singleton pattern out for free, right? So when the name is the same here, you can say calculator 0 and C dot memory, and when you say memory plus, you can just you get copy method also for free, which you saw early on in Java code. We have to do new calculator. That's exactly the same thing. You just call add, pass in, and you get new instance of calculator right here.
So you're trying to avoid mutating things. You're trying to avoid, so even in object-oriented code, you can actually completely remove mutation if you want it. It would be quite inefficient if the language wasn't rigged for it. So I encourage you to explore that, and maybe we can look at the other melodies. If there's any questions around referential transparency, bring them on. But we can also then look at the rest of the melodies. Any comments about that?
So in object-oriented languages or typical languages with immutable data structures, if you try to do this, the overhead is quite large because you don't have efficient implementation of immutable data structures. So that's something to watch out for. I mean, just because the code becomes manageable, you might try to go to the other extreme and compromise on the efficiency.
Absolutely. So that's why in functional paradigm, you'll hear the word mutability a lot, meaning you don't have arrays that you're mutating. You keep returning new arrays, new this, new that. You never change anything. But as Aditya says, if you keep returning new things, you're wasting space. But it turns out there are quite sophisticated ways of copying and sharing that actually does that very efficiently. So Scala does that, Clojure does that. These are called persistent data types.
Persistent data types, exactly.
So it's something that I encourage you to just explore it, and referential transparency actually will take you into further downstream all the implications of function learning.
I think referential transparency opens a lot of questions, like the one which you said, and then
You have a question?
Yeah. Sometimes when you are calculating, let's say we have to store this memory variable. So in Java, I think object-oriented is quite simple. The variable is not final.
Yeah.
So any new value is getting added, it will be stored there. But in function programming, if only pure functions are there, how do we can handle it?
But how do you actually mutate things?
Not mutate, but to refer the current or refer the global verifying
Maintaining a state line.
maintaining state.
So I'll say one thing, and there's actually a melody for this on streams. But if you think of a variable x, and we're iterating through it, we keep changing it. So we're in a for loop, and we keep changing that value. Well, let me make it more specific. Customer balance, bank balance, right? That's something that typically in object-oriented it will be a variable on a class, and you'll be changing it all the time. So the way to not change things is to keep the whole history, and to say a customer balance is not just sitting in a variable, it's a list of balances. So as the balance changes, you return a new collection with a new balance. And so that's a fundamental way of avoiding mutation and actually having immutable data structures instead of a mutating variable.
In this case, they chain of false there. And I think Java, if you call the function recursion, it throws a cap. I think around 5,000 or something, it throws you an exception.
Yeah.
You
So
can
it's
chain functions with a nested function.
absolutely. So Java is not made for that. Java is made for mutability. Absolutely.
so there is no tail curve optimization in Java in that sense. But I don't know if that's an interesting. So the stack can overflow.
So Same case can happen in functional programming. We are changing this field at some point of time, maybe will be.
Oh, you see, so in functional programming languages, and you'll find in the recursion, maybe let's just keep it on the high level. In recursion, the melody, you'll see that different languages, they actually, these functional languages implement efficient recursion that has constant stat space, which you don't have in Java. So that's something you can learn more about. It's quite a deep rabbit hole that we can't go into right now. But recursion is actually efficient in functional programming languages, particularly tail call recursion. And so in Java and C# and that, you don't have that kind of efficiency because you don't need it. You typically don't recurse. So you might have learned from, if you learned programming in an object-oriented language, which I actually did, it's one of the things is never ever recurse. And in functional, you want to recurse often. You actually often don't explicitly recurse. You might use higher order functions to recurse. So these are the 9 things that we so far. I mean, there would probably been more, but we just stopped because this conference came on. So, but maybe you can also describe some of these for us.
Well, if you feel like you have some other code here you want to contribute, please send us a pull request. We'll put your code there. Go through these melodies. So.
For instance, this one is quite a big deal in terms of coming from object-oriented programming. You're constantly thinking of, oh, I have a customer. And the customer has an address and an email, and you kind of draw these object blocks to model your domain. So how do you do this without objects, without classes, without class hierarchies? And so that expression problem actually shows how you would do that kind of thing in Haskell, in Clojure, in Scala. Have a look at that if you're interested in modeling functional programming.
There is this interesting one which is lazy sequences. You know what? Coming from object-oriented world, we are used to process collections in batches. Like we perform one operation on the collection, then perform the next operation. But you know what? Sometimes that's an overkill. I draw an analogy there to much like our SQL databases. Where you do a select star from and you do join between 2 tables, where you select everything, all the tuples, and then only to filter out what you really want. So here, if I have a map and a filter, for example, right, in a collection, right? Well, first I will do a mapping operation to, let's say, I had a list of numbers, I square them, and I want numbers less than 10. Then I would have to map all the numbers to squares, and then only to filter out ones which are less than 10. What if I just pass only the ones, one at a time, to the pipeline, and just be lazy about it? So that's what I was referring to. Just do only a little bit to do what you want and get the result. So being lazy is going to help you here. So those are lazy sequences that we have kind of gone through.
And so you'll see that in any functional programming introduction. Quite soon they'll start talking about laziness. So we did this in a few languages, and I think it's quite a nice way to get to the heart of it quite quickly.
Yes, so this is what we were talking about. If you have a range, just that's what you do.
Great. So that's just to invite you into the material. Half of what we just got through probably doesn't make sense, but I encourage you, if you're interested in going deeper into functional programming, I think a great way to learn is to look at the different language lenses and explore that feedback. Let us know if it's helpful or not, if it needs more detail or not. Okay, so let's leave it like that because we wanted to really finish with the discussion. We've actually got officially 15 minutes there, but since we started late. But let's have a discussion now about how to build your language program. What language should you be using? Because this is a fair question after a session like this. What language should I use? What is the best language? And so first I want to say that there is no answer for that. It really depends on where you're coming from, where you want to go. But let's have a broader discussion about this very topic. And see if for some of you, we might even in this discussion be able to point you at the sweet spot language for you. Because it's really going to depend on maybe just tell us what
so I'll just read out. So basically, I have this quadrant here, and on the left is the FP paradigm, on the right is imperative programming paradigm, below is dynamic, and below is statically typed languages. Yeah. So we have C# here spanning across from imperative to FP. We have Scala again spanning this whole thing. Java 7 just up till here. Haskell is statically typed and FP. And a totally functional programming language with Java, it has this kind of span from here to here. JavaScript, on the other hand, is it's dynamic language and it has its span right from here to here. And Ruby also.
I would say Scala is here.
Yeah.
Smack bang in the middle between FP and imperative.
Yeah.
Scala is sitting here. Interesting thing, C# has been steadily migrating its way towards the. So these languages are actually moving as they evolve. So there's Scala, you probably but so Scala is.
No, it's actually probably crossing here, but it's just not visible here.
I would put Haskell is right here. Haskell is kind of off the.
Let me quickly
top to the left.
change the thing here, but yeah.
Turn off the lights a little look better.
Yeah, but the white color is not, but the white is there. But yeah, you see Scala is spanning right from.
So Scala is great if you're coming from Java. Scala is really, really good. It's going to be the most comfortable write into functional you can have, I think. I don't know. I mean, I'm sure that's arguable, but it's going to be a good write.
So I think the way I would like to answer that is you pick what you want to do. If you want to shift paradigms, Scala is a good one because it will give you. It's statically typed. We all come from. If you come from Java background, Scala would help you there. So it's a bridge language to jump paradigms, to go from one paradigm to the other. Whereas if you want to go from static to dynamic typing, and at the same time, bit functional, bit functional, then Groovy is good one. But if you want to go pure functional, Clojure is the one. So pick, there are many possible paths, we're not saying.
And there's also, you'll often hear people say Haskell is a very powerful language. I said earlier also to learn functional. But you're not going to be speaking it in your day job, most likely. But that doesn't mean it's not a very interesting language. It's probably, if it's your kind of thing, if you have a mathematical background, for instance, Haskell is probably the shortest route to functional. So let's open it and hear from you. What have you checked out? What would you like to? Over to you.
Groovy Scala.
Groovy?
Yeah.
Groovy or Scala?
I'll go with Groovy for now.
Then Scala.
Oh.
That's a good migratory path.
So Groovy is less tough.
It's dynamic, it's dynamic typing and closures and other things that just out of the box.
Yeah. Closure is kind of, I like Closure because I like Lisp. But if you don't like, if Lisp isn't your thing, I wouldn't go there at all because it's just going to hurt your head. But if Lisp is your thing, it would make your day. You know, it's a beautiful language. So, I mean, I would also say, pick a language that thrills you. This is the most important thing. That's the only way I pick things. I fall in love with the language and I go into it. And so really listen to your passion there. If it looks beautiful, go for it.
Yeah, or be adventurous, try out something completely different. Yeah. But I would lastly like to tell you that be patient with yourself whenever you do this, because when coming from one programming paradigm, we tend to write code which reflects our thinking in that old one. So don't kill yourself over that. It's okay, we all do mistakes. So one of the things is to probably in your production code base, if you wanted to inject a new language, test base is a good place to start with.
Test with another language.
Test with another language and make sure it's interoperable with the production code base. But don't be, I mean, go give it a try. I think the important thing is to give it a try.
Yeah. And I hope after a Jugalbandi like this, you can see it's very, you don't have to marry a language. You can do a few. And you can just touch a language a bit and get an impression of it. And touch another one and strikes your fancy a bit deeper. So I encourage you to be more, being a polyglot is more accessible than it might seem. Because we come from a history of learning. If you're into C#, for instance, it might feel like you've spent so much time, or Java, you spend so much time learning the ecosystem and the development environment and everything. It feels like you're really losing your investment in a way. But I really want to say that it's not the case. You're actually going to find that all your C# and Java is going to come in handy, and you're not going to lose your investment in that. And new languages can be shorter and smaller and easier to get into than a big old language like C# or Java, which is tied so heavily to the ecosystem. A lot of these new languages have smaller, surface areas. So what do you want to learn? I would like to know, if anything, and really, I'm not asking a leading question. What is your next language? What I would like to know.
Actually, just one comment. There are a few languages which was not worked on before. They will sort of shape your foundations a bit and help you broaden your horizon. And they're worth learning just for that. And to me, those two languages have been Scheme with SICP and Haskell. So, I mean, I've never written production code in Scheme. I'm pretty sure in the near future I'm not going to be writing any production code in Haskell. But just to broaden the horizons and change your mindset about programming in general, these two languages are quite good. And just worth trying them out for that.
And you really bring some, I love both of those languages, and you can really, when you get deflated from your current language, because spending too much time in one language is also boring.
Yes, it is.
And so you can really get some free energy and passion from the new language.
Oh, this is how it's done there. Huh? Much better now. Probably. I see that myself doing it.
And Java 8, is that interesting for anyone? You being a Java person, are you heading there?
Not
Yeah,
your production code library.
okay.
For my own needs, I define
Similarly, actually, I think for C#, if I was a C# dev, I would go straight for F#.
Yes.
F# is a very amazing language.
I'm already exploring it and sharp is the next exploring. That's my next destination.
Great.
But probably what you had said earlier that like the environments of Java and C# are so big then every other day. In the .NET world, there is something new which comes up every other day. So that language itself, learning into that paradigm itself is taking a lot of time.
Yeah.
So yeah, probably small things like these would really help in learning the bigger languages.
Yeah.
In another way.
Yeah.
But again, in like the Java JVM ecosystem, I mean, the languages are on ILR. You have the interoperability, so you have the flexibility to try new rather than on the same production code as well. If you want to do so. That's an additional advantage.
And Xshop is really, it's very Haskell-ish. It's kind of a sister language of Haskell, but also influenced by it. Very, very interesting. I would go straight for that. By the zoo. Great. And then JVM, what else did you do with Java developer? What else is interesting? Ruby? Have you looked at Ruby? It's quite nice to get all the types of your back. Just kind of like
Yes.
have it lighter.
You're traveling light, but then you have to be disciplined as well.
Yes.
There's also JRuby.
Yes.
JRuby?
If you want to try Ruby but stay in the JVM language, you can go for JRuby.
Well, I think Ruby is an interesting language. I really enjoyed Ruby. Really enjoyed it. So I have a high regard for it. But as getting into functional, I wouldn't say it's interesting. It's quite deeply object-oriented with some nice little functional bits. As we saw that Lambda thing, you don't quite have a strong functional base.
So can you consider being in a hybrid world?
That's a very good point. Very good question. Like if you look at Haskell, it's so pure, it's as pure as you get. No mutation, no variable in Haskell, nothing. Scala, you have val and var. Clojure, you have a similar thing, variables and values. And in my opinion, these hybrid languages are probably the way to go. In terms of a production setting where you need to do the things that you're used to doing, these hybrid languages are absolutely where it's at because you do mutate. So the thing about when we're talking about referential transparency, you want to maximize the purity, but where you actually want mutation, you want to be able to do it. Because in Haskell, if you want to simulate mutation, you have to work quite hard. You can do it, but you work at it. So these hybrids are great because they allow for both. And I think these so Scala, Clojure, Ruby probably also.
Yeah, I think Scala is a little better candidate as well.
Yeah, but Clojure also, in terms of mutability and not, so not in terms of FD, but in terms of mutability and not, pure functional mutability, Scala and Clojure have a similar approach of perfectly hybrid.
Yeah.
You can go in any piece of code, you can mutate when you need to, but you can minimize it. So
in Java or C# or other languages, you have to work hard for immutability, whereas in Haskell you have to work hard for mutability.
and in Scala and Clojure, you don't pay that price.
Yeah.
You get cheap.
The middle ground.
So as a takeaway, can we think of, supposing if you already have a language which you're using, they have for regular work, the functional paradigm is prescribing or say some practices are there which require language support, and there are things which does not support. So pick up the good parts and you use them. The advantage is numerous that we already see for functional programming.
I think at the end of the day, like anything, we have to play on strengths.
But absolutely, I think the thing is you can carry much more into a hybrid language of what you know. So that eases your path in, and you can take your time. When I learned functional programming, someone gave me great advice because I was kind of going, what language should I learn? And they said, give yourself 10 years. You know? And at first I was shocked and horrified. But I think it was the best advice I got in the long run because it was really a case of actually I'm not going to care about it. It's not a matter of learning it. It's not going into it and going into it as deep as you need to. You know, if you're doing production code and a place with a lot of mutation, can get a bit more functional to start out, but you don't have to go all the way.
I think we are out of time now.
Yeah. We could call it a workshop,
Yeah.
and we can put some more afterwards.
Yeah. I hope you can give us open feedback. You enjoyed, didn't like. It's a small retrospective if we could do before we leave.
I mean, I'd be happy if over a meal if you liked it. You can tell me if you didn't like it and put the ball. So let's just, but I certainly I hope you got something out of it. I hope you can see a path a bit more clearly, at least the next few meters ahead. And if that's the case, then I'm happy for you.
Sure.
Right. Thanks.
Thank you.